How could you check to make sure those graphs are correct? So do notice you have that r of x is equal to x plus 3 times m of x. You can't put it in that way, but if you know what m of x is, you could rewrite r of x here, put it into the calculator and check yourself. Okay? Yes, sir. So yeah, you need x with r of x. And I saw Kadeja doing this earlier, and I want to commend this. Right? Writing out the point off to the side if you need to.
Oh yeah, rule.
Let's do
This graph.
Yes, it was boom.
I didn't even hear it.
All right.
I don't know.
Jaquan, every point is an x and a y, right? So Jaquan, see this first column here, that is our x. And then this column here, that is my y. There's the point. Okay? Now, as a quick reminder, if your graph does not look like this, notice I only have points right now, but if your graph does not look like this, my guess is you forgot to pay attention to the scaling. What is each line here? Twos. Do not forget to pay attention to that scaling because that can impact things significantly. Alright? Now, I want to show you something that I saw a student do in first block, and I want you to tell me if this makes sense and have reasoning why. Or if you make, let's put it this way. Do you want to ask a question about it or push back on it? So this is what a student did in first block. So that's what they did to connect those points. Connects those points pretty well. Does anybody want to push back on that or ask a question about that?
The arrows.
The arrows?
Arrows are straight.
Do you want to, what's your question about the arrows?
Are they too straight?
That's a good question, right? So I will point this out. As long as it's not going completely vertically, I'll be okay. You can actually see the fact that the line is covered up here, and then the line is a little bit to the right of that curve. So it is still going down and to the right. That's okay. Yeah, and it's approaching this, so it's still going to the right, or going to the left. Anything else that we want to push back on?
You can't.
Let me turn off the lights so you can see a little bit more clearly.
You can't have a vertex of a single point.
So, okay, so actually, you talk about this down here?
Then, oh, well, that, or that right there.
This one right here? What's the issue up here?
You can't really go above it,
Going above the x-axis before he gets to the point.
because it doesn't totally cross.
How do you, okay, so you're talking about the issue that it's going through the x-axis, creating a what then? If it's going through the
It
x-axis?
creates another zero.
Say that one more time.
It creates another zero.
Or I think someone over here said a root. Can I just magically create a new zero? No. And this is something that you have to pay attention to. The only zeros, which remember zeros, how are the zeros seen on the x-axis? As x. Say it louder. Intercepts, right? On the graphs, zeros are seen as x-intercepts. You can't just magically create a new zero. So how many zeros are there actually supposed to be? Only two. Right now there are 1, 2, 3. Okay, so this does not quite work, and that was something that a lot of students, one student in particular, had a lot of trouble seeing. We cannot do that. So can I get a volunteer to show us how they created this curve? will check it. So I need someone to volunteer about how they would connect these points. I need you to stop being scared. I'm just scared of cats. Okay? So here's the thing, guys. Please understand, I'm okay with mistakes. In fact, I like mistakes. We can learn from mistakes. So, who will volunteer to show us a way to graph this? Come on, Preston. Okay, so we do read it from left to right. There we go. Okay, sir. So what do you think about that? First off, does it go through all the points? Yes. It does not create another zero, but it does hit that zero, doesn't it?
Go on me, buddy.
That's unfortunate. I was like, I hit something, that's bad. Alright, I'll get with that in just a second. I hope I didn't break that. I like that mug. Yeah, that's it. Alright, I'll deal with that more in a second, but I got it. Okay, so again, how can I quickly check to see if this is correct? What do we have at our fingertips? Graphing calculators, right? Now, can you type it into the calculator like this, x plus 3 times m of x? No? So how would I write r of x then? So I need the x plus 3, but what am I going to substitute in the place of m of x? X minus 1 times x plus 3. That's what m of x is equal to, isn't it? Alright, so let's type that into the calculator and see what we get. There she is, x plus 1 times x minus 1 times x plus 3. Maybe I want to shift it down just a little bit. But does it... Oh, I have stuff written on the board, it makes it kind of hard to see, doesn't it? So does it do exactly what Preston predicted of just touching the x-axis and then going back down? Do not forget, the number 0 is in between what sets of numbers? Positives and negatives. Notice right here, it was negative before the 0, and it is negative after the 0. There is a chance, right, that we just missed the positives, but when there's just that 1 0 like that, it's going to touch the x-axis and go back away. What are your questions looking at this graph and looking at what you have on your paper? Cool. B. There are some small differences between this degree 3 function r of x and the degree function p of x, which that's from number 2. So p of x is number 2. So I want you to start brainstorming some ideas. I'm going to give y'all, let's say, 90 seconds, all right, to look at at p of x and r of x, and what are some similarities and differences. 90 seconds, go.
That's a bone.
I can memorize anything. I said, yeah, you got it.
It's not stressful.
It's okay.
Well, just pack it up and go home.
Thank you. Thank you. So let's get some ideas flowing. What's a similarity that we noticed?
Both are cute.
They're both what? Cubic. Okay, so I want to pause and point this out. We say it's a cubic, and that is true. What would be the degree of that function then? It'd be, well, so it'd be x cubed or a degree of 3. But earlier I talked about the fact that the degree matches the number of what?
Zeros.
Number of zeros.
That only has 2.
Does it only have 2 zeros?
R of X has 2.
No, they got
P of X has 2.
but we got 2 times 0.
So here's something we need to be careful about. This is one reason why zeros or roots are slightly different than x-intercepts. How many x-intercepts does it have? 2. It only has 2 x-intercepts. It only has 2 different zeros, but when I look at the function x plus 3 times x minus 1 times x plus 3, the negative 3 just shows up twice. And so we're actually going to talk about that. Ms. Courtney, is that in 2 lessons? The idea of the multiplicity? Lesson 4, I think? Something like that? Okay. This is the same 0, but we would count it twice, is the idea. So that match, it still has 3 zeros, just one of them shows up twice. On the graph, it would only be that one x-intercept. Okay? So it's cubic, so it is a degree 3 still. Alright, any other similarities? Say again? So they both have increasing and decreasing. Anything else that's similar?
The shape.
The shape, very important to notice. That shape is very similar. Anything else? Okay. Yeah, how many factors? How many factors?
3.
1, 2, 3. Right? So 3 linear factors. Okay. Remember those 3 linear factors are connected to the 3 zeros, which end up being 2 x-intercepts. Does anybody have anything else to add in similarity, or should we move to differences? I was like, get me out of the similarities, Mr. Kenny. All right, so differences. What do we see?
R of X only has 2 x-intercepts.
R of X only has 2 x-intercepts. That's the really big difference. Anybody have a guess as to why? This is what we're going to focus on here. Why does R of X only have 2 x-intercepts? I want to point this out. So that's -3 comma 0, right? So you see how that has that one x-intercept as zeros, it shows up how many times? Twice. If a 0 shows up twice, you're not going to go through the x-axis. It's going to touch the x-axis and go back away. That's something to notice here, and we'll see more and more of this as we look at future lessons. But we want to note double roots. That's what we call it. Why do you think we call it a double root? Because it's the same thing twice, right? It's double. So a double root slash 0 is where the function touches the x-axis and goes away. So it doesn't cross. It intersects it, it touches it, but it does not cross through that x-axis. That is an important distinction to notice here. Whenever you have that double root happening, it's not going to cross through that x-axis. It's going to touch it and go away. Doesn't look like it broke. What are your questions before we move to activity 2.3 and practice this? Okay, so please note here, okay, this is activity 2.3. This is putting all of this information that we have learned over these two lessons, or activities 2.1 and 2.2. So you might want to go back and look at those, but it's putting it into play. If I were you, I'd probably have a separate sheet of paper out to create tables on, because there's not a whole lot of paper here, or a whole lot of space. That's just me. There's free paper up here if you need it. At most, one person per group. No, John, you need to write this down. I know. Okay. Now, this is the last time I will remind you of this, but I need you to pay attention to this. We are taking f of x, which is a what type of function? Quadratic. Please note, f of x is equal to x minus 1 times x plus 1. That's this function right here. That's that parabola. I am taking that function and I am dilating it by x. Well, I have f of x, I'm dilating it by just x, okay? What is the first thing I need to do in order to try to graph this dilated function? I need to find my what? X-intercepts, also called zeros. How can I find those zeros? One, I can look at the graph. What zeros do I have? Okay, right here. Negative 1 and 1. With my dilated function, will I have a new zero? It's not? That's negative 2?
No.
Ah, this is why I'm going over this. Hey, before you start graphing, you need to pay attention to your scales. How can this be negative 2 if this is negative 2? Oh.
It's going by halves?
I don't know. But look at your equation. Look at that equation. The equation should also tell you what your roots are. What is the zero here? X equals 1. And x equals negative 1. So those have to be negative 1 and 1.
Right.
So what is the scale going by? 0.5. So you might want to label your scale before you get going, because it will make your job easier. Okay? So you do want to pay attention to that detail. But again, I'm going to ask an important question. Are those the only zeros that we're going to have?
No.
Does anyone know what the other zero would be? Remember, I'm dilating by a linear factor, so I should get another zero. How'd you get 0?
Because if it's linear, it's going to like go through the origin.
Doesn't have to go through the origin. Maybe it's not x equals 0. So I want y'all to remember, this 0 came from here. This 0 came from here. What's my other linear factor? Isn't that the new linear factor that we're dilating by? And remember, the way that we find zeros is by setting the linear factor equal to 0. So it's x equals 0. What are your questions at this point? Thanks, sir. So, please make sure you make your table, or if you're just going to graph, just go by the graph. Now, I do want you to keep in mind, we're taking f of x and we're dilating it by what? X. Well, I already have x here, so do I need to make another column? It's just x times f of x. You don't need another column like we've been doing, because it's just x times f of x. Now you may need another column for future problems. Do your best to graph it, identify those points, but what can you do to check yourself after you graph it by hand? Put in the calculator, keep that in mind, right? You can graph it on the calculator to see if your answers are correct. Let's work with each other, check in on each other with your x values, check in with each other on your tables to make sure that we all agree, because if we have different answers, you need to talk it out and hash it out. Check with each other, help each other grow and learn. Let's graph these points and let's get to work. Yes, we have.
You was talking.